Hi, this is our video on permutations and combinations. I believe that you have some familiarity with this from Algebra 2, so hopefully this is more of a review lesson than anything else. So one of the main things that students have a difficult time with relative to permutations and combinations is knowing which one is which and which one they mean to use in a given problem. So sort of a silly way maybe to remember which one is which is to think about which one needs to be more complicated. The word permutation, maybe that just sounds a little more complicated. Oops, I meant to highlight it. So maybe the word permutation just sounds a little more complicated. And it's true that in a permutation, every little detail matters. So what I mean by that is order is a big, big deal. Alice, then Bob, then Charlie is considered completely different than Charlie, Bob, and Alice in that order if we're talking about permutations. However, on the other hand, combinations are easygoing, okay? The details aren't as, persnickety, aren't as particular. So in combination world, Alice, Bob, Charlie, that's the same darn thing as Charlie, Bob, Alice. It really doesn't matter. So if you try to connect the idea of order is the big deal. So permutations are for when you're making a list, like first, second, third, that kind of thing. Order matters. Whereas combinations are when you have groups and order doesn't matter. We're just in a pack together. Okay, that's a combination. So let's start with the mathematics behind permutations. In permutations, remember, we care about every last detail, especially the order of the items. So let's say we have 8 people. Let's say that they're running a race or something. And we're wondering, in how many ways can we give a first place, a second place, and a third place prize or medal among these people who are in our competition? Well, we conveniently had names that were alphabetical there, A through H. So here's a little picture that could represent what's going on. If they were all racing, let's say it happens to turn out that Alice is in first place. So Alice gets our gold medal. Now, once Alice has crossed the finish line, she can't also be second place. So now we only have 7 choices available for our second place winner. Let's say our second place winner turns out to be Bob. And then once Alice and Bob are both away, both through the finish line, there's only 6 choices available for that bronze medal. And so if we think about the mathematics of that, we really want to just do this math problem. 8 times 7 times 6 is going to give us the number of different ways in which, out of our group of 8 people, we might end up giving the medals. So we had to order 3 people in order to do this. This first number was the total number that we had available, and then 7, and then 6. And we had 3 numbers because we were putting 3 people in order. We took 1 away each time because after one person already got their medal or crossed the finish line, so to speak, they were no longer in the big group of people. Now, that problem might remind you a little bit of something called a factorial. Factorials are those things that have exclamation points. And so 8 factorial, for example, is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so that's something that I know you've seen in the past, like a long, long time ago, like last year. Okay? And so this question maybe looks a little bit like that, except we don't want to go all the way down to 1. We want to get rid of or not include 5, 4, 3, 2, 1. We want to get rid of that part. Well, a way to get rid of it would be to divide by 5 factorial. And so you can see here I've written out 8 factorial all the way down the top here and 5 factorial all the way down the bottom. And what that does is the common factors cancel out and leave us just with that 8 times 7 times 6 that we wanted. You might wonder why we bothered to write this out, but if you think of a problem that would have a lot more numbers, like let's say 376 people are in a marathon and we want to know how many ways we're going to award the top 12 runners, you can understand that we wouldn't necessarily want to just write out all of the numbers and multiply them. We would like to have a formula like this. Now, you might wonder, why did we use 5 factorial? Why not some other number? Well, the place that the 5 came from is from taking our total number in the race, which was 8, and subtracting how many people we were going to give awards to, which was the 3. And so that bottom number is really from 8 minus 3, and then we just threw a factorial on the end. And this suggests the general formula. So anytime we have n objects, and from those n objects, we want to put k of them in order. Then our formula is this thing that you see on your screen, the n factorial over n minus k factorial. This is actually built into your calculator, so I would love it if you don't have your calculator handy. Pause the video to go get it. Because once you have your calculator, what I'd like you to do is to go to the math menu. And actually, before you go to the math menu, I'd like you to type in 8. And then in the math menu, you're going to pick the thing that says NPR. Now your calculator just uses the letter R instead of the letter K. It means the same thing. So you're going to put that command on your screen, and then you're going to type that. Okay? And this will give us the same exact answer that we got by hand, which was 336. So let's just make sure that you get that on your calculator. And I think it's really important that you try this, because if you haven't tried it on your calculator and you think you know how to do it, but then you don't, we aren't going to know that unless you've tried. So this is a problem that we know the answer to. It should be 336. Try it and make sure that you're doing the right thing, okay? All right, from here we're going to go on to combinations. Remember, in combinations, order doesn't matter. They're a little more easygoing. You can mix it up, and they still just count as one combination. So let's say that, in this race, I'm kind of a cheapskate. I can't afford like bronze and silver and gold medals. So I'm just going to give empty tin cans as prizes, okay? And those 3 tin cans are identical to one another. I'm just wondering now, how many different ways can I have that group of 3 finish that's going to get the tin cans? Now, because the tin cans are the same, it really doesn't matter the order in which they're awarded, because the prizes are identical. So if I end up giving a can to Alice, Bob, and Charlie, that's really the same result in the end as giving a can to Charlie, then Alice, and Bob. They're going to be equally disappointed no matter what. So the deal is, we need to take care of those redundancies. We want Alice, Bob, Charlie, and Charlie, Bob, Alice only to be counted once, not twice. So in order to do that, we need to think, well, how many ways can I mix up, say, a group of 3? A group of 3 has 3 times 2 times 1 permutations. And so we are going to take that number and divide the number of permutations by the number of ways that those groups could be rearranged, so that the rearranging doesn't get counted over and over again. So if we have those 3 tin cans to give away, there are 3 factorial, or 6 variations, for every group of 3 that might win our little race or contest here. So what we're going to do is figure out how many permutations we had, which we already did before. We figured out there's 336. And we'll divide by the number of repeats, which we find by taking the factorial value of our small group. This should suggest our new equation. So remember that our equation before for permutations was n factorial over n minus k factorial. To figure out how many combinations we have, we do exactly the same thing. We find out how many permutations there are, but we don't want the different mixing up of the orders to be counted separately the way we do with permutations. We want it to be counted the same. So to adjust so that we aren't counting them separately, so that Alice, Bob, Charlie, and Charlie, Bob, Alice are exactly the same group and aren't counted differently, we are going to divide out by the repeats. And the number of repeats is always the small group that we're picking, factorial. And we divide by that so we don't count them over and over again. So this formula is also found on your calculator in the same menu as before. So in our case, let's take our 8 people, and then let's find that command. The command is in the math menu, and it's NCR. C is for combination, and they just use an R instead of a K, but it's honestly the same thing. So we just pick that command, and then we also take a 3. And I think we already figured out the answer for that to be 56. So this answer, when you try it on your calculator, should be 56. Please try it and verify that you know what you're doing, okay? If you get 56, we know you got the right command and you get it, okay? And if you don't try it, we have no idea if you understand or not. Okay, so please do try. All right, on the last little bit here, we have 5 example problems. I'd like you to pause the recording, try the problems by yourself, and then after you've tried them all, come back and see if your answers are right. Okay, welcome back. Take a minute to check your answers. Okay, in the first one, we use combinations because you are picking a subgroup you are not putting in order. In example 2, we use permutations because you are putting the letters in an order, like in a secret code or a word that doesn't maybe make sense, but sort of like a word. So you're taking all 5 letters and putting them in a sequence. That's a permutation. In example 3, remember that there are 4 8s in a deck of cards, and there are 4 7s in a deck of cards. And you're not putting these in a sequence, you're just getting them in a jumble, in a hand of cards, like while you're playing a game. And so that would be 4C3 times 4C2. The C is sometimes read by the word choose. So it's out of the 4, you're choosing 3. Out of the 4, you're choosing 2. I know you're not literally like choosing like in the sense of looking at them and picking which ones you want, but you're hoping to pick or hoping to get that distribution of cards. In example 4, it's a permutation because you are assigning roles to each of those 3 people that are different from one another, and so it's more like the gold, silver, and bronze medal than like the 3 tin cans in the lesson, okay? Example 5, you're using combinations because you're not putting anything in order, you're just deciding about picking a subgroup to be tested. 8C3 is how you figure out the cards themselves. 11C4 is how you figure out the subgroups for trucks. And you want to do both of those. And so as we've talked about, and in probability world means multiply, not add. So we would multiply those 2 answers to get 18,480. All right, thank you so much. The lesson that you just witnessed, I took some examples from a great website that I found online, so I just wanted to give credit to that because I'm not trying to break copyright, I'm just giving credit where credit is due. I'll see you in class. Thank you so much. Please bring your notes and come ready to do some problems. Thank you.